Hello, 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 and welcome back to another tutorial. We are just going over more general tips and tricks, and today we are talking about limiting your types. Or not limiting, but choosing the right type. So we just discussed limiting your types, and this is about choosing the right type. So hopefully you've already watched the limiting your types video. I already talked about kind of some discussions about uh, just just kind of limiting all the way down to as small a space of options when you're choosing the type as you can. But we kind of glazed over choosing the right types. But yeah, we discussed this a little bit in that video, so I would definitely encourage you to go watch that one. This is just kind of a more nuanced dive into some of the topics in there, just specifically choosing the right type. So I made a lot of assumptions with you being able to just discern that, you would start with a string for the username, but for some people, that might be actually pretty difficult to figure out right at the get-go. So I just want to kind of have a more general discussion about that. This will probably be a shorter video because once you know kind of what the general standards are for some of these data types, you don't struggle with them as hard. And especially once you start to manipulate a SQL database, you'll kind of already have these baked into your head. These are just very common data types. So what I want to start off with is a user info. So a user info for people that are new to database design, usually we kind of there's kind of two different takes on it. So you might have a user object or a user database object that stores things like the username of that user and the password, stuff like that, like very common attributes for that user. And then you might have a user info table next to it that stores a lot of other information about that user. Or someone might say that actually they break up the user info into lots of different attributes tables that are spread throughout the database. So there's a lot of different takes on how to do this for database design, but for us, let's just assume that a user info is just all the info about a user that we have on them just within our entire system. So if you could even think about this, like think about if we were building a scraper. So our user object up here, and I'll just define it up here. Our user object is very generic, very usable in a lot of situations. It just stores their name, and it stores maybe it stores the address. No, I'm not even going to store that. It's like all it stores is really their name, maybe their age. Okay. Now, the first thing you might ask me is, how did I think of these data types? So, and this, as I say, this is just a deep dive into that discussion. So, why choose a string for name and why choose an int for age? Now, this is not necessarily a discussion on if limiting the types. So, these are not necessarily the, I guess we are choosing the right type. So yeah, like why would I choose a string? Why would I start off by choosing a string for the name and an int for the age? So the reason I might choose that is because the name, when you write down, a string is a string of characters, right? So it can be A, B, C. It can even be 1, 2, 3. Though I wouldn't recommend an all int string like that. It could be 1 AC. It could be Tammy and Tom. So a string can be any variation of this. It can actually be the entire thing with the commas included and commas and spaces. So when we look at kind of the heart of what a string is, we start to kind of look at characters. And so if we look at char value, well, now character gets broken down into just 256 possible values. And if you don't know what a character table is, you should look it up. Pretty easy to find on the internet. You can actually character table. So look up ASCII. So an ASCII. So here's just what an ASCII table might look like. It's just these are all the possible representations and conversions from a number into their character counterpart. So this example seems only. So yeah, here we go. So here we get to our letters. And you can see the kind of the name. This is the lowercase letters, and here's our uppercase letters over here. And here are our numbers, our actual numbers here. So this is always what we're talking about when we're saying characters. So string of characters means that it's a string of these characters. Now an ASCII is not necessarily, an ASCII is one way of looking at a character. So an ASCII limits is one representation of these characters in a space of 256 possible characters. But there are other different types of representations that can fit within a character space. And then you have things like Unicode that break out of that and use even more. So a character takes up a byte of space, whereas a Unicode might take up, I think, 4 bytes of space, like for each possible representation inside of it. So, once again, go look that up, go explore that. That talks about kind of all the different types of characters that you can have in a string. But it's important to kind of note that a character, when we're just thinking through a problem, a string is a string of characters. So a character can be any of those 256 things that we saw. It could be any of 256 things that so one of the things that we might say is that when we're looking at something like a name, a name might only ever exist in this space. It might only ever exist in the uppercase space. But it may never take up any of these other things over here. So it may never be able to be any of these other values. So when you're choosing the right type, you're kind of asking, is it okay for it to have a little more room outside of exactly what I need? So ideally, what you don't really need a string for the name. You need an alpha numeric. I don't know what it would be like. It wouldn't be an alphanumeric string. You would need just like a string of alphabets. So ideally, there would be some data type that limits the strings or the characters in this name to only be characters that were like ABC and capital versions of this. So you could make that data type yourself and use it widely within your program. And it would probably be a very useful character to just indicate that, hey, these are only alphabets. Or you could perform some reggae, and that's likely what's happening on your UI. Whoever your UI dev is, they've coded some regex to only accept characters from A to Z, and then uppercase A to Z as input. Maybe they also include a space. So that's one thing to think about too. One thing we also discussed is that a name is more. A name might also have, it could be something like Mr. Sir Sam, Mr. Sam Clinton. A name could be something like that, right? And so, you can see that a type also starts to give you more room in some of your edge cases. So before we were saying that, well, we want to limit it from characters A to Z. Well, now we would break on this period, and we would actually break on these spaces in between here. So maybe we don't want to code up cases for every single one of those, and we're okay with just kind of going willy-nilly and having some allowances for some of these extra characters, and we don't necessarily want to code up a regex that just checks and only it allows dots and spaces through it, but only the dots are in the right space, right? We maybe don't want to go through all the work of coding a regex, so we just code a string. But it's important to understand that that's the trade-off that you're making. Is when you choose a string allows any value to be input into this space. And it's why I would argue that strings are probably the worst data type. They allow coders to be extremely lazy without thinking about things ever. Like a lot of people will start out by just saying the name should be a string, and they'll move on to the age and just move on, and they'll code their program that way. And sure, 80% of the time, people will type in name the proper way. But the reality is that 50 years down the line, names aren't spelled that way, the same way anymore. And so now your code is starting to break because someone can't go overload the string object with a name object instead, right? And if you had defined a name object, then someone else could come down here and they could have written over the name object with a different way of orienting your names. Or say that you go over to Japan and there's a different structure to their names from the way that it is in the US. Well, if you could have defined a Japanese name struct and passed that into here, then it could have been a simple swap. But because you didn't do that, now all your code's breaking in Japan, and you have to recode a lot of stuff. You made a lot of assumptions with the formatting of string that you never captured in your code. And so that causes a lot of maintenance cost for yourself in the future, especially when you're scaling out and going to new regions. So that's why it's so important to choose the right type when you're coding, and to be aware of the concessions that you're making, or just count out the assumptions that you're making. So I think, and this is pretty hard to do. It's so easy to put string on here and move on to the next problem, but you should be aware of what you're saying when you say string. I am storing my name as a string. It means that I am okay with all characters in a Unicode table, all the possible characters in a Unicode table being stored as values for this. That is a way of coding a solution for storing a value like this. And it is not the optimal way, but it is the easiest way. And so I've made that decision, and so I move on. So choosing the right type doesn't always mean that we code a very, very tight specification or a very tight contract on the value that's being stored in this variable name. So a very tight contract would be something that says an optional, essentially a regex that's like, there will be a Mr., a Miss, a Mrs. clause here, and then there will be a dot and a space, and then there will be a first name, and then there will be a dot and a space, and there will be a last name, and there will be maybe more names adjoining it, or there will be a hyphen after this. So a very tight contract could limit too much, right? So if you define a really tight contract, you might actually break on cases that are useful to you. So it can be hard to figure out all the edge cases for all the different types of names that exist out in the world. And so that's in that making a concession towards that, you say, I'll just use string then as a type so that I don't have to worry about all the different types of ways that I can code a name out to be. Because it can actually be really, really difficult to think about all the space of the names. And so it's okay. It's not saying that string is not the right value to put here, but we're choosing that type because it is exactly the right type to put in here with the concessions that we already have in mind. So choosing the right type does not always mean that we have the tightest contract for that value. It means that we have mentally gone through examples and we believe that this is the right type given the resources that we currently have. Now, if you're like me, you're a solo person on a project that you're building out and you have a lot to get done, of course you're going to use string for the name and move on from it. But it needs to still be a question that you have of, well, should I think about a problem that I might have 20 years down the line and think about this a little bit more? Okay, well, maybe I can't think about it right now. I'm going to put a to do above it, and I'll think about this name a little bit later and make sure that this is the right way of going about this. And if I'm making any strong assumptions later on in my code, then maybe I can reflect that here instead of later in the code. So if in my code I have a regex that is making sure the name is exactly this kind of format, maybe I add that regex here to the user object instead of later on in that piece of code. So that's one example to think about here. So and then thinking about age along the same lines. Age is a value that will always be from 0 to some crazy it's actually not that crazy high of a number, in fact. So age is something that will go from 0 to, like, I don't know how old the oldest person is right now, but maybe like 120, right? So and certainly now we have to think about what's the context of the age. Well, it's a human that we're talking about here. We might not be talking about a dog or a cat who are going to have, relative to humans, much shorter lives. So that's something to think about too. Int ends up being a huge amount of space to be storing, I think 2 to the 32nd or 2 to the 64th. Like, that's, whichever one it is, it's a huge amount of space to be storing for age, a value that could actually be stored in a byte. But once again, most people's instant reaction will be to store the age in an int. And the reality is that you don't need an int to store the age. Now, this gets into hyper optimization. A byte is a lot harder to work with, unfortunately, within our code than it is to use an int. And it confuses a lot of people, so I don't expect something like this to ever catch on. But, you should be thinking about this, right? A byte has a range of 0 to 255. Your age has a range of 0 to 120. A byte would be the optimal. I mean, honestly, a half byte would be optimal for storing age. But we don't have a half byte. So a byte is the smallest data type that we could have used to store our age for this user. And I would argue that would be the optimal type for choosing your age. But like I say, your age being stored in a byte will confuse most people. Most people will argue that the space consumed is not that important. But it is still important to go through the exercise of thinking that age is 0 to 120, while byte is 0 to 255. Now, on this point, and why certain decisions like this might not actually stand the test of time, imagine if there's a breakthrough and we somehow are able to cease aging and people can live till they're 300 years old. Well, now all of our code is has a bug that's been designed into it because we said, well, humans in 2022 didn't live past 120, but now we have humans living until they're 300. So when we get to 255, well, we'll either suffer based on how our code is. We'll have either like an overflow, or people will start to be reversed right back to age 0 once they start to hit 256, right? So that's another thing to be thinking about when you're choosing the right type. So we ended up getting stuck on 2 very, very basic values, but this just shows you the thought process that should be happening when you're thinking about the types that you have. And as you face more and more problems, you'll kind of carry that experience with you and just say, well, I know to use age as an int because it just prevents that problem of it breaking in the future. Whereas if I choose a byte, while I might be right in 2022, I'm not protected in the future with other things. Or now my code is no longer extensible past humans. So I can't use this for a tree, for instance, because a tree might live for 1,000 years. And so now I'm changing code in this tree to allow it to be. But once again, code for the problem that you're solving right now. If you are a human user and this data type is only storing values for human users, well, code for the human user that you have right now. It's not your fault if you break in the future, but just know that those are some of the considerations that you might have for a certain value, especially if it's a piece of code that might last a really long time. So you don't want your contract to be too restrictive, but you don't necessarily need it to be too loose either. So, and now let's just kind of dive into some other examples really fast on things that you might just think about. So quickly, we'll do things like the address of a person. Maybe. So why choose string for address? So if you watched my video before on limiting your types, we talked about how string is not a very good data type for an address, but it can be in certain situations. So say that you aren't going to use this address for anything. So if a human was going to come and use this address to do something, well, a human can decipher an address pretty easily and format it correctly and use it for something. Whereas a machine would need this to be broken into streets and a city and a state and the zip code. And so you would, if you were going to send this address off to a machine, it would be better to store it in a data type that delineated all of those different values. And if you want to see how we do that, go look at the previous video on limiting your types. But if this were going out to a human, string is good enough for us. And especially in our scraper's case, our scraper might not be able to figure out whether or not the address, it can't figure out all that stuff. Like it can't delineate streets and city names and all that stuff. It came in as a string, and so string is the best that we're going to get. We're just maintaining the type here. So our scraper found what looked like an address, but all it could do, it can't parse it all out. It just stores it as an address, and it's like, okay, that's okay, because keep in mind that this example, we're building a scraper. So when we're scraping the internet, what else might we find? Maybe we'll find out if someone's alive. So is alive. Now, what might be a good data type to store for this? So instantly what goes through my head is someone is either alive or they're not. There's really not, in between state. There's not really a state outside of that in the context of this program. So someone's heart is either beating or it is not. And there's no machine. Kind of alive is to us, that gets philosophical, but alive to us means they are breathing and moving around and they're not under the ground somewhere. So in that case, we know that we've actually limited the space of options down to 2 spaces. They are alive or they are not alive. And we've said that there's no in-betweens and there's nothing outside of that. So the most limited data type is a Boolean. Now with some of the other examples, we talked about how, well, what if in the future there is a third option for being alive? But like I say, in our case, we can't code out too far into the future. So say that someone can come alive for the second time. We can restart their heart, or we can upload their brain into another consciousness or into a robot body, and now they're alive on live 2. Well, that's not something that our contract can be aware of right now, and so we're not going to worry about it. We're going to think about the world that we live in right now. I say build your code for about 20 years. So in the world that we live in right now, and in the next 20 years, we kind of expect that people are just going to either be alive or not be alive. But we aren't going to think in 2020 when maybe people can come back to life as robots. So let's move on from that. What's another value that we might find on the internet for somebody? Maybe we find their income. Okay. So we somehow find their income. So this is a good one. So when we think about the range of values from here, someone could be making, someone could owe a lot of money. But we're not going to think about their net worth, but net worth would be a great one to think about after. But income is just how much they're bringing in a year. So someone's either bringing in money, and then there's an upper bound on this. The upper bound's fairly understood at this point, but we'll just say it's like $1 billion. So like okay, so we said that the upper bound is $1 billion that someone could make. So for this one, and there's no, but there actually are decimals in this value. There's only 2 decimals. So this is probably the annoying thing about using floats and doubles, is that you can't choose a precision. But here we're only precise up to 2 decimal places. But if we use something like a float or a double, it's going to give us a lot more space than that. But we'll just go ahead and store this income as a double because it is a decimal. But like I say, we understand that a double is way too precise for what we care about. And in fact, one thing that you might say is that, hey, I actually want to store this as an int, and I'm going to multiply by 100 just to get the value stored as an int. And then I know that wherever I use this, I need to divide by 100. And so, and maybe that's even a data type that you can code up. You can code up an income, or maybe you maybe call it a cash value data type. And that cash value data type, every time you use it, it divides itself by 100. And then every time you store something in it, it multiplies it by 100. So, that's a decision, but you understand the trade-off here is that, using a double is way too much data to take up, because its precision is huge. It can give you like 30 decimal places or something. So it's like, it's way too precise because we only care about 2 decimal places. And so a smarter way and a more space conscious way might have been to just store it as an int and then multiply it by 100 and move about it that way. And these are concessions. So now we're thinking about a concession on the system. So like I said, we have a good understanding of the range. In the next 20 years, we don't really expect people to be able to make $1 trillion in income, but maybe we would like to have some room in our program. Maybe Elon Musk goes to Mars and explodes a nickel industry. There starts a nickel import industry, and now he's raking in $1 trillion a year from mining asteroids in space. And so it's like, okay, we want our program to be robust up to that. And so, and it's actually, and so like this is where you do want to make sure you're checking that your int even can store the capacity of this, because you might have no choice. You might have to start expanding out your int if you get too many commas out, and you might have to start going to a long, and long longs and unsigned ints and stuff like that. So, and that's actually a good point too about the age. Is we notice that our age never goes negative for humans. So if you had chosen int here, and if you were a stickler on int, I would tell you make that a uint, so that people just know that this is always going to be a positive int when they look at it. So the same with your income. It's so we really only ever go from 0 up to $1 trillion. So we might say, we can't unsign that. But if we had done the int method, we would have made that an unsigned int multiplied by, or we divide it by 100, or multiply to 100 to get to that end. So that's that value. Now we look at net worth, and net worth might feel like it's very similar to income, but net worth can be actually a lot more than income, especially if you start to evaluate the properties that people own and all that. This can quickly get into the trillions of dollars. And especially if this were something that were evaluating a country, or maybe it was evaluating monarchs, and somehow our system was able to figure out the real estate value that someone owned. So that it would start to get into the trillions. So once again, we have something that can go up quite far. It can go up quite far, and maybe we just say 100 trillion, right? Say someone owns a planet. Right. So it becomes, and like I say, these are all kind of like made up scenarios, and these are not necessarily things that you might bring up in a design discussion, but you have to be very aware of the problem space that you're solving for. So you want to make sure that the contracts that you make are robust for the problem that you're trying to solve. So if you feel like you're scraping the internet and you might come across an article that says that this person's net worth is $100 trillion, well, then you want to make sure that you can store that value properly. You don't want it to be that you miss out on that value and then you have to, something throws in your program and you have to go solve that explicitly. And you don't know how many times that might throw. So, okay. Now, the only thing about net worth is that it's not necessarily lower bound by zero. Net worth can go in the opposite direction as well. And so, here becomes the first example of where we actually needed the negative on this value. So if this were an int and we were doing that int method, now we couldn't just go to an unsigned int. We would actually need that negative portion of the int. So let's just say that we can get maybe a lot trillion into debt. I don't know if I'm using the right number of commas. Probably not. I think that's 1 million billion trillion. So blah 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 4 blah blah blah. So I'll delete this. Okay. Wait. Blah 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 4 blah blah blah. Oh nope, that's wrong. Okay. Cool. Anyway, so that now becomes the range, and like I say, we can be decimals here. So right now we feel that double is the right range, but like I say, we can still do some of the tricks that we were doing with the income on there. Just we wouldn't be able to use a uint, we would use an int instead. So but yeah, we end up resolving that double is the value that we want to use for net worth. And that's how we would move on. Now, what might be an example of something that we would split out? So like I said, our parser finds an address, and it's not going to really be able to split out the address into street names and cities and all that stuff, unless the HTML had tags that gave it clues on all of that stuff. But our parser might just see an address and plop that into its database and keep moving. So, but what's something that it might kind of piece together for us? Keep in mind that a parser really just looks at element tags on an HTML page, and then usually just scrapes the text out of that tag. So you can have smarter parsers that scrape the page and looks for things that look like addresses, but for the most part, it's just gonna grab that whatever's in that tag and keep moving. So something that might look it's pretty tough, but one thing that I can think of is maybe a list. We might start to form some kind of list of social media sites. So social media sites. So if we were building a scraper and we found profiles that matched the same name as this person, or maybe start to match on address and stuff like that. And so what would you store those sites as? So, those sites, website URLs kind of form. Well, I mean, that's actually the question. Are you going to save the URLs? Are you going to save the name of the URLs? And that's actually probably a perfect example of something that you maybe would say, I'm going to store that as a struct. And, you might come down here and just define the structure of that struct. And you're able to say that it has a name, it has a URL. I'm going to actually save that later. And okay, I'll leave it at that. So the website has a name and a URL. So why would I choose name for the social media site? So a social media site can conform to certain params. There's it usually is going to follow alphanumeric. It might have a few special characters in it, so there are some restrictions that we could place on that social media site, but our parser, we're keeping it pretty stupid, so it's going to grab the name as a string, and so we'll store it as a string. We won't try to regex it or anything like that. But the URL is actually a very special type. So we know that URLs have to follow a certain convention in order to be resolved by any browser or anything that wants to go to that URL. It actually follows this URI standard. And URI is a library that you can call into from most languages. Looks like I'm not going to be able to use it right now, but yeah, here's an example of where we would actually want to just store it as a URL or a URI. In this case, looks like I don't have a certain library here. This usually resolves pretty quickly on PC, but not as easily on Mac. But you would want to store that URL as a URI type because C# is going to already have all these formatting rules that it's going to know for you for that URL and make sure that it will make sure that it conforms to all of that for you. So, oops, I just had it. Okay, cool. My bad. Had it all uppercase. So, yeah. So now we have this URL stored as a URI, and now we can use it as a URI, and we know that it follows all these rules, and it will even crash our parser and tell it, hey, that's not a valid URL. Maybe you need to retry finding the URL for this website before you store it. So, and that is that. And what happens here is that you can even have a predefined list of social media sites that are valid values for a user to have. So you might have a separate scraper that filled out this list of social media sites on the internet, and then maybe it has like a tag, like some section of tags, and but yeah, I'm not going to get into all of that, but yeah, maybe it has a list of tags for what it is all about. Like, is it entertainment, or is it kind of about movies, or is it about general, and is it about politics? So you could have all these tags that were auto put onto it. So here it is. There are definitely a lot of other data types out there, and of course this list gets more complicated as you create more data types, but I think that's what I want you to get in the habit of, is just thinking through all this stuff a lot, like pretty quickly. Now, the reality is that, a lot of these, for people that have been coding for a while, were just defaults that you went to, and you might not even know why you went to them as defaults, but they're just kind of what you code up as defaults. And that's okay. But what's important is to just kind of keep in mind why you have that convention in your head, and what was the process that you went through of choosing those types in the past. and make sure that the assumptions that you made in the past are still valid for today. So, as I said here, you might not, an int is not, might be overkill to use on a pet. So, just as it's overkill to use on a human. So, is there a chance for you to be a little more specific about the on that animal? And I think that people use int pretty lazily when a uint is actually the data type that they should use. And I would say that while you might not want to use byte for age because people might be confused by it, I would certainly encourage you to use uint a lot more, and make yourself get in the habit of asking, do I really need the negatives on this number? Because if you start to use uint a lot more, then your compiler is going to catch more of the exceptions for you. It's going to catch your if statements that kind of that don't evaluate anything, and your if statements that aren't helpful for the problem that you're trying to solve. And once again, they give clues to people that use your code that, hey, oh, this is interesting. This person thought about the age never being a negative number. So maybe I need to be aware of that as well. So in terms of the space consumption, that's rarely a concern in 2022, the space consumption. But eventually, sometimes it is. If you're coding in languages like C++ and you're doing a lot of operations quickly, then it really does start to become important to limit this data type as tightly as possible. So, after going through this video, I hope you kind of understand that there's all these levers that you're pulling as a dev in the back of your head. And you're saying, do I care about like super, super, super duper optimization? No, I don't care about it. So there's a whole list of solutions that I'm going to eliminate because I don't care about that. And then, do I care about being very, very clear to the person that reads after me? Yes. Okay. Now that filters out a couple of options there. And then, you click enough levers, and then you finally look at your solution, and the possible set of solutions comes out to about 3 different options maybe. And then you just pick the one that you feel like is the best. And sometimes they're all equally good, and you just move on, and you just randomly choose one, and you keep moving on. So yep, that's about it from there. Thanks a lot for tagging along in this video. Hopefully it ended up being pretty short. But yep, I will see you next time for the next video. Thank you.